Electricity is everywhere. It powers the screen you're looking at right now, lights the room around you, keeps your food cold, charges your phone while you sleep. Because it is so familiar, most of us assume we understand it. But try answering a simple question. What actually happens when you plug something in? Where does the power really come from? What is electricity at its core? Most people give answers that sound reasonable. Electricity is energy. Electricity is electrons moving through a wire. But those answers don't actually explain anything. They simply rename the mystery. Electrons move, yes, but why do they move? What pushes them? And why does that pushing suddenly create light, heat, or motion? The uncomfortable truth is that electricity is far stranger than the way it is usually taught. Once you look a little closer, you realize we are not just using a convenient technology, we are manipulating one of the most powerful and bizarre forces in the universe. Try a simple experiment. Tear off a strip of plastic wrap. Hold it between your hands and rub it quickly, the way you would rub your hands together to warm them on a cold day. After a few seconds, stop and hold the strip of plastic close to the back of your hand. Do not touch it. Just bring it near your skin and wait for a moment. If you pay attention, you will feel something strange. The tiny hairs on your arm begin to move. They slowly rise, leaning toward the plastic as if something invisible is reaching out and pulling them. Nothing touched your skin. No battery, no wire, no machine. Just a piece of plastic that you rub for a few seconds. And yet it can tug on your body through empty air. Pause and think about what just happened. In everyday life, we are used to forces that require contact. If you want to push a chair, you must touch the chair. If you want to lift a book, you must place your hand under it. Every force we experience seems to involve two objects physically pressing against each other. Our brains are built around that assumption. Force means contact. Motion means something touched something else. But the plastic wrap experiment breaks that intuition immediately. The plastic is not touching your arm. There is a small gap of air between them. And yet something is clearly happening. Something invisible is reaching across that space and pulling on the hairs of your skin. Most people recognize this as static electricity and stop thinking about it. We remember doing similar tricks in school. Rub a balloon on your hair and stick it to a wall. Shuffle across a carpet and touch a metal doorknob and feel a tiny spark. Pieces of paper jumping toward a plastic comb. These demonstrations are so common that they feel almost like party tricks. But that reaction hides something important. What you are witnessing in that moment is not a small curiosity. It is the visible effect of one of the most fundamental forces in the universe. When you rub the plastic wrap between your hands, you were not just creating friction. You were moving electrons. Your skin and the plastic exchanged tiny particles of electric charge. Some electrons were scraped from your hands and ended up stuck on the plastic surface. Now, the plastic carries a small excess of negative charge. It does not take much. Even a microscopic imbalance is enough. Those extra electrons sit on the plastic and something remarkable happens. They begin to influence the world around them. The hairs on your arm are made of atoms. Inside those atoms are charged particles as well. The negative charge on the plastic pushes and pulls on the charges in the atoms of your arm hair. The atoms shift slightly, the hair responds. And suddenly those tiny strands start leaning toward the plastic as if gravity itself had tilted sideways. But gravity is not responsible here. The force acting between those charges is far stronger than gravity. It is the electromagnetic force. What makes this force so strange is that it does not require contact. It reaches across space. The plastic does not need to touch the hairs for the interaction to happen. As long as there is charge present, the force can extend outward and influence other charges nearby. Even though the distance is small, The principle is enormous. The same type of interaction that lifts the hairs on your arm is also responsible for holding atoms together, allowing chemical bonds to form, and making matter itself stable. That little strip of plastic is quietly demonstrating a rule about the universe. Charged particles can push and pull on each other even when they are separated by empty space. There is no string connecting them, no mechanical rod transferring the force. Instead, the interaction is carried by invisible electric fields that spread outward from every charged particle. When another charged particle enters that field, it feels the force immediately. Once you realize this, the simple experiment starts to look very different. You are not watching a toy trick. You are watching the electromagnetic force revealing itself, the same force that shapes the structure of atoms and molecules, the same force that allows your nerves to send signals and your muscles to contract, the same force that modern civilization has learned to manipulate to create electric power, motors, computers, and communication systems. And all of that begins with something as ordinary as rubbing a strip of plastic and noticing that the hairs on your arm rise toward it through empty air. When you rub that strip of plastic between your hands, something very specific happened at the microscopic level. Electrons moved. Your skin and the plastic exchanged tiny charged particles. Some electrons were scraped away from the atoms on your hands and ended up sitting on the surface of the plastic. The plastic now carries a small excess of negative charge. That imbalance might sound dramatic, but in reality, it is unbelievably small compared to the total number of particles involved. You may have transferred a few trillion extra electrons onto the plastic. That sounds like a huge number. But matter contains astronomical numbers of particles. Compared to the total number of electrons already present, this is barely anything. And yet, that tiny imbalance is enough to make the hairs on your arm stand up. The reason is that the force between electric charges is staggeringly powerful. To see how powerful it really is, imagine something extremely simple. Take two electrons and place them 1 centimeter apart. That distance is huge compared to atomic scales, but it keeps the thought experiment easy to visualize. Now ask a basic question. How strongly do these two electrons interact with each other? Two forces are acting simultaneously. Gravity pulls them toward each other because everything with mass attracts everything else with mass. But electrons also carry electric charge, and like charges repel. When you calculate the strength of these two forces, the result is almost impossible to believe. The electromagnetic force between those two electrons is about 10 to the 42nd power times stronger than the gravitational attraction between them. 10 to the 42nd power. A 1 followed by 42 zeros. That difference is so large that gravity might as well not exist at the scale of atoms. For planets and stars, gravity dominates because enormous masses accumulate and electric charges mostly cancel out. But at the scale of electrons and atoms, gravity is essentially irrelevant. Electromagnetic forces control everything. They determine how atoms hold together, how molecules form, how chemical reactions happen, and how materials behave. If gravity suddenly disappeared tomorrow, the structure of atoms and molecules would remain almost unchanged. But if the electromagnetic force vanished, matter itself would collapse instantly. There would be no atoms, no chemistry, no solid objects, no life. This realization leads to a very strange question. If the electromagnetic force is so unbelievably strong, why is the world around us so calm and stable? Why are objects not violently repelling each other all the time? Why does your body not explode from the electric forces between its own particles? With forces this strong, you might expect the universe to be a chaotic storm of charges pushing and pulling in every direction. But that is not what we see. Instead, the world appears solid, quiet, and mostly stable. The explanation for this is one of the most important ideas in physics. Cancellation. Every electron carries negative charge. But inside atoms, there are also protons, which carry positive charge. Positive and negative charges attract each other with the same enormous electromagnetic force that makes identical charges repel. In ordinary matter, these charges are mixed together in almost perfect balance. Each positive charge is surrounded by negative charges, and each negative charge is surrounded by positive ones. Their forces oppose each other and cancel almost exactly. The enormous pushes and pulls are still present. But because they are balanced, the net effect becomes extremely small. Matter appears neutral. This balance is incredibly precise. In most objects, the number of positive charges and negative charges is nearly identical. The cancellation is so effective that the gigantic forces remain hidden from our everyday experience. But when that balance is disturbed, even by the tiniest amount, the underlying strength of the electromagnetic force suddenly becomes visible. That is exactly what happened with the plastic wrap. By rubbing it, you change the balance by only a tiny fraction, perhaps one extra electron out of trillions. Yet that slight imbalance created a force strong enough to move the hairs on your arm. So the calm world we experience is actually a delicate equilibrium, hiding unimaginably powerful forces. Everywhere around you, electrons are repelling each other with enormous strength, while positive charges pull them back just as strongly. These forces are locked in a precise balance that keeps matter stable. But the moment that balance shifts, even slightly, the true power of the electromagnetic interaction reveals itself, and that is only the beginning of how strange electricity really is. To understand why the world does not fly apart under the enormous strength of the electromagnetic force, you have to look closely at how matter is built. At the center of every atom sits a tiny nucleus containing protons. Each proton carries a positive electric charge. Surrounding that nucleus are electrons, each carrying a negative charge. These particles obey a very simple rule that governs the behavior of electric charge everywhere in the universe. Charges with the same sign repel each other. Charges with opposite signs attract each other. Positive pulls negative. Negative pulls positive. Positive pushes positive. Negative pushes negative. The rule is simple, but the consequences are profound inside ordinary matter. Positive and negative charges are packed together in incredibly tight arrangements. Electrons gather around nuclei, attracted by the positive charge of the protons. At the same time, electrons repel each other because they all carry negative charge. The result is a delicate balance. The attractive forces between opposite charges pull structures together, while the repulsive forces between identical charges prevent everything from collapsing inward. At the atomic scale, matter is not static or rigid. It is a continuous negotiation between enormous pushes and pulls that almost perfectly cancel each other. That cancellation is the secret that keeps the world stable. In most objects, the number of positive charges and negative charges is almost exactly the same. Every proton in the nucleus is matched by an electron somewhere around it. The attractive and repulsive forces balance so precisely that the object as a whole becomes electrically neutral. From the outside, it appears as if nothing special is happening. You hold a mug, a book, or a piece of wood, and it feels ordinary and calm, but underneath that calm surface, unimaginably strong forces are pulling and pushing in every direction. They simply cancel each other so well that their effects disappear. Think of it like a tug of war between two equally strong teams. If both sides pull with the same strength, the rope does not move. From the outside, it looks like nothing is happening, but in reality, both teams are pulling with tremendous force. The forces are still there. They are just balanced. That is exactly what is happening inside matter. The electromagnetic forces between charges are huge. But because positive and negative charges are mixed together so evenly, their effects neutralize one another. This balance is not perfect forever. If the balance is disturbed, even slightly, the hidden forces become visible immediately. That is what happened when you rubbed the plastic wrap earlier. By transferring a tiny number of electrons from your skin to the plastic, you created a small excess of negative charge. The plastic now had slightly more electrons than protons. That tiny difference broke the perfect cancellation that normally hides electromagnetic forces. Suddenly, the extra electrons could push and pull on other charges nearby. The imbalance was small. But because the underlying forces are so enormous, the effect became strong enough to move the hairs on your arm. What makes this idea remarkable is the scale of the imbalance required. You do not need to move a large fraction of the electrons in an object to create noticeable electrical effects. Moving one extra electron out of billions of billions can already produce measurable forces. That tells you just how perfectly balanced ordinary matter normally is. The charges cancel with extraordinary precision. The universe hides gigantic electromagnetic interactions beneath a thin layer of neutrality. This hidden balance changes the way you should think about solid objects. When you hold something in your hand, it feels solid and stable. But that solidity is not because the particles inside the object are tightly packed like bricks in a wall. Instead, the atoms are held together by the balance between attraction and repulsion. Positive charges pull electrons inward. Electrons push each other outward. The structure that emerges from that balance creates the materials we recognize as solids, liquids, and gases. In other words, matter exists because enormous electromagnetic forces cancel each other almost perfectly. If that cancellation did not happen, the world would be completely different. Matter would not sit quietly in stable form. Atoms could not exist. Molecules could not form. Chemistry would be impossible. Life would never appear. Everything around you depends on the quiet equilibrium between positive and negative charges. The stability of the entire physical world is built on that hidden balance, a balance so precise that we rarely notice the immense forces it is concealing. Pick up a mug and hold it in your hand for a moment. It feels solid, stable, and completely ordinary. Your fingers wrap around the surface, and you instinctively believe that your skin is touching the ceramic. That seems obvious. After all, that is how we describe the experience. We say we are touching something. But when you look at the physics of what is actually happening, the situation becomes much stranger than it appears. In reality, the atoms in your hand never truly touch the atoms in the mug. What you are feeling is not contact. What you are feeling is the electromagnetic force pushing back against you. Remember what an atom looks like. A tiny nucleus sits at the center, surrounded by electrons occupying a region of space around it. Atoms are not solid little balls. Most of the space inside them is empty. When two objects are brought close together, the electrons in the atoms of one object begin interacting with the electrons in the atoms of the other object. Because electrons all carry the same negative charge, they repel each other extremely strongly. As your hand approaches the mug, the electrons in your skin begin to push against the electrons in the ceramic surface. That repulsion becomes stronger and stronger the closer the atoms get. Eventually, the repulsive force grows large enough to balance the force from your muscles pushing inward. When that balance is reached, your hand stops moving closer. At that moment, you feel what your brain interprets as touch. But nothing has actually collided in the way your intuition imagines. The atoms never merge or overlap. The electrons simply refuse to occupy the same region of space. They push back with enormous electromagnetic force, creating the sensation of pressure in your nerves. The firmness you feel is just the strength of that repulsion. There is always a tiny gap between the atoms in your hand and the atoms in the mug. It is incredibly small, far smaller than anything you could see, but it is there. The surfaces never truly meet. This means something surprising. Every time you think you are touching an object, you are really feeling electric charges pushing against each other through space. The sensation of hardness, texture, resistance, and pressure all come from electromagnetic interactions between electrons. Your brain interprets those signals as contact, but the underlying reality is different. What feels like a direct mechanical interaction is actually an invisible force field interaction at the atomic level. Once you realize this, it changes the way you think about all physical forces in everyday life. When you push a door open, you might imagine your hand physically shoving the door forward. But what is really happening is that the electrons in your hand are repelling the electrons in the door. That repulsion transmits through the atoms of the door and causes it to move. When you sit in a chair, you might think the chair is supporting your weight through solid contact. In reality, the electrons in the atoms of the chair are pushing upward against the electrons in your body, preventing the atoms from collapsing into each other. When you walk across the floor, every step is supported by electromagnetic repulsion between the atoms in your feet and the atoms in the ground. Even friction works this way. When you slide your hand across a surface, microscopic irregularities in the atoms of the two materials interact through electromagnetic forces. The atoms tug and resist each other, converting motion into heat. The warmth you feel from rubbing your hands together is simply energy produced by those countless tiny electromagnetic interactions. This perspective reveals something extraordinary about the nature of the physical world. What we call mechanical forces are not truly fundamental. They are just large-scale consequences of electromagnetic forces acting between atoms. The push of a wall, the resistance of a table, the tension in a rope, all of these everyday experiences arise from the same underlying interaction between electric charges. The electromagnetic force is doing the real work. Everything else is just a macroscopic expression of it. So when you hold that mug again, remember what is actually happening. Your hand is not truly touching the ceramic surface. Instead, billions of electrons in your skin are pushing against billions of electrons in the mug. The forces are balanced so precisely that the mug remains steady in your grip. What feels like simple contact is actually a delicate equilibrium of enormous invisible forces acting across incredibly tiny distances. In that sense, throughout your entire life, you have never truly touched anything. You have only felt the electromagnetic force pushing back against you. Now that we understand how powerful electromagnetic forces are and how they quietly shape the physical world, we can turn to one of the most common misunderstandings about electricity. Most people imagine electricity moving through a wire the same way water flows through a pipe. The picture seems intuitive. Electrons leave the power plant, travel down the wires, enter your house, pass through a device, and finally return somewhere else. In this model, electricity behaves like a stream of tiny particles rushing through metal conductors. But that picture is deeply misleading. The reality is far stranger and far more interesting. Inside a copper wire, there are already enormous numbers of electrons. Copper atoms contain electrons that are only loosely attached and can move relatively freely through the metal. These are often called free electrons. They are already there long before you flip any switch. The wire is full of them at all times, quietly drifting around in random motion due to thermal energy. When a circuit is open, nothing organized happens. The electrons move randomly in all directions, and their motion cancels out so that no net current flows. The moment you close a switch, something changes. A voltage difference appears across the wire. That voltage creates an electric field inside the metal. The field pushes on the electrons, encouraging them to drift in a particular direction. But here's the surprising part. The electrons do not suddenly shoot through the wire at high speed. In fact, their average motion, known as drift velocity, is extremely slow. In a typical household wire, electrons drift only about 1 millimeter per second. That is roughly the speed of a crawling ant. At that rate, an individual electron would take many minutes to travel across a room, and yet when you flip a light switch, the lamp turns on almost instantly. If the electrons themselves were responsible for carrying energy all the way from the power plant to the bulb, the light should take a long time to appear, but it does not. The response is essentially immediate. Something else must be happening. The key to understanding this is to remember that the wire is already full of electrons. Imagine a long line of people standing shoulder to shoulder. If the person at one end of the line is pushed forward, they will push the next person who pushes the next, and so on. The person at the far end of the line feels the push almost immediately, even though no single person traveled the entire length of the line. The motion was transmitted through the chain of interactions between neighbors. Electric current in a wire works in a similar way. When the electric field appears, it pushes on the electrons near one end of the wire. Those electrons nudge the electrons next to them, which nudge the next one, and the effect propagates through the entire conductor. Each electron only moves a tiny distance, but the influence spreads rapidly. The push travels along the wire at nearly the speed of light because it is carried by the electromagnetic field surrounding the conductor. This means that electricity is not really a stream of particles racing from the power plant to your home. Instead, it is the rapid propagation of an electromagnetic influence through a medium that already contains movable charges. The electrons themselves drift slowly, but the signal that organizes their motion spreads extremely quickly. That is why a circuit can respond almost instantly across large distances. Understanding this changes the way you should imagine an electric circuit. The wire is not a pipeline delivering electrons from one place to another. It is more like a system that allows electromagnetic forces to coordinate the motion of charges already present throughout the conductor. When you flip a switch, you are not sending electrons on a journey. You are creating an electric field that spreads through the circuit and gently nudges billions of electrons into collective motion. The lamp lights up because the electrons inside the filament begin moving and colliding with atoms there, generating heat and light. Once you see it this way, electricity becomes less like a flowing substance and more like a pattern of forces moving through space. The energy that powers your devices does not come from a tiny group of electrons racing down the wire. It comes from the electromagnetic field that organizes the motion of charges all along the circuit. That field is the real messenger, carrying the influence from the power source to the device in your hand. If electricity is not simply electrons rushing down a wire, then the next question becomes unavoidable. Where does the push actually come from? What is creating the electric field that organizes all those electrons inside the wire? To answer that, you have to trace the circuit backward. Imagine the lamp in your house. One wire runs from the lamp to the wall outlet. The outlet connects to wires hidden in the walls of your home. Those wires join larger lines outside. And those lines connect to transmission cables stretching across cities and landscapes. Follow them far enough, and eventually they lead to a power plant. Somewhere, perhaps miles away, perhaps hundreds of miles away, there is a massive machine spinning, and that spinning motion is what ultimately powers the light in your room. Inside a power plant, you will usually find a large turbine. Water falling through a dam may drive it. Steam produced by burning fuel or by nuclear reactions may push against its blades. Wind might turn it. However it happens, the result is the same. A heavy shaft begins rotating at high speed. Attached to that rotating shaft are coils of copper wire, and surrounding those coils are strong magnetic fields. When the wire spins through the magnetic field, something remarkable happens. The magnetic field pushes on the electrons inside the copper. Those electrons begin to move. Their motion creates an electric current. That device is called a generator, and it converts mechanical motion into electricity. The connection between magnetism and electricity is one of the deepest discoveries in physics. For a long time, scientists believed they were separate phenomena. Electricity involved charged particles. Magnetism seemed related only to certain materials like iron. But experiments in the 19th century revealed a hidden unity between them. Moving electric charges create magnetic fields. Changing magnetic fields create electric currents. They are not separate forces at all. They are two aspects of a single unified interaction. The electromagnetic force. A generator uses this unity directly. As the copper coils rotate through a magnetic field, the magnetic environment experienced by the electrons inside the wire changes continuously. That changing magnetic field exerts forces on the electrons, pushing them along the wire. Once those electrons start drifting, the electric field spreads through the connected circuit and influences electrons everywhere along the wire network. The push travels outward, eventually reaching homes, factories, and devices many kilometers away. The spinning motion of the turbine has been transformed into electrical energy moving through the grid. What makes this even more fascinating is that the process can run in reverse. If you send an electric current through a wire placed inside a magnetic field, the moving electrons interact with the magnetic field and experience a force. That force pushes on the wire itself, causing it to move. This is the principle behind an electric motor. In a motor, electricity flowing through coils of wire creates motion. In a generator, motion creates electricity. The same physical laws govern both devices. The direction of energy flow simply changes. This symmetry between generators and motors is the foundation of modern electrical technology. Power plants convert mechanical motion into electricity using generators. That electricity travels through the power grid and eventually reaches motors inside machines, appliances, in fans, pumps, and vehicles. Those motors convert electrical energy back into mechanical motion. Energy moves from falling water or spinning turbines into electromagnetic fields, through wires across vast distances, and finally back into motion again. There is another remarkable example of the link between electricity and magnetism that appears everywhere in the power grid. Consider a transformer. A transformer contains two coils of wire placed close together but not physically connected. When an alternating current flows through the first coil, the moving electrons create a changing magnetic field around it. That changing magnetic field extends through space and passes through the second coil. As it changes, it pushes on the electrons in that second coil, causing them to move and creating a new electric current. No direct electrical connection is required. Energy passes from one coil to another through the magnetic field, linking them. This ability for changing magnetic fields to influence electric currents across empty space allows transformers to increase or decrease voltage levels in power lines. High voltages are used for efficient transmission across long distances, and transformers adjust those voltages before electricity enters homes and businesses. Again, the mechanism is the same fundamental interaction between electric charges and magnetic fields. Once you see how generators, motors, and transformers all operate, a clear picture begins to emerge. Electricity and magnetism are not separate phenomena, but different expressions of a single unified force. Motion can create magnetic changes. Magnetic changes can move electric charges. Moving charges can create new magnetic fields. These interactions form a continuous loop that allows energy to move from spinning turbines to glowing lamps and rotating motors. The entire electrical infrastructure of modern civilization depends on this deep unity between electricity and magnetism. By this point, the picture should be starting to change. Electricity is not just something that runs through wires or powers devices. It is the visible side of a much deeper phenomenon, the electromagnetic force. And once you realize that, something even more surprising appears. Almost every physical experience you have in daily life is actually an electromagnetic interaction. The forces you feel, the light you see, the structure of matter itself, all of it traces back to the same underlying force acting between charged particles. Think about the simplest action you perform every day. You push a door open. It feels like a mechanical interaction. Your hand presses against the surface and the door moves. But at the atomic level, there is no direct contact. The electrons in your hand repel the electrons in the atoms of the door. That repulsion travels through the atoms of the door and causes the entire structure to move. The motion feels mechanical to you, but the true force involved is electromagnetic. The same is true when you sit in a chair. The chair seems to hold you up because it is solid, but the solidity comes from the electromagnetic repulsion between the atoms of the chair and the atoms in your body. Without that repulsion, you would pass straight through the material. Walking across the floor works the same way. Each step is supported by electromagnetic forces pushing upward against your feet. The ground feels firm because the electrons in its atoms resist being pushed into the electrons in your skin. Even friction, the force that slows motion when surfaces rub together, is an electromagnetic phenomenon. When two materials slide across each other, the atoms on their surfaces interact through countless tiny electric forces. These interactions convert motion into heat. The warmth you feel when rubbing your hands together is simply energy released by electromagnetic interactions between atoms. Now consider something that seems completely different. Light. Light is not a stream of particles bouncing through space like tiny bullets. Light is an oscillating electromagnetic field. When the filament inside a light bulb becomes hot, the charged particles inside it accelerate and emit electromagnetic waves. Those waves travel through space and eventually reach your eyes. When the oscillating fields encounter the electrons in your retina, they push those electrons into motion. That motion triggers chemical reactions in specialized cells, which then send electrical signals through your nervous system to your brain. Your brain interprets those signals as vision. Once again, the entire process is electromagnetic from beginning to end. Chemistry works the same way. The bonds that hold molecules together are created by electromagnetic forces between electrons and atomic nuclei. The shape of molecules, the reactions that occur between substances, the structure of DNA, and the complex machinery of living cells are all governed by electromagnetic interactions. Biology itself is built on chemistry, and chemistry is built on electromagnetism. Every nerve signal in your brain, every contraction of a muscle, every heartbeat in your chest depends on the movement of electric charges responding to electromagnetic forces. What makes this realization profound is that the electromagnetic force cannot be explained in terms of something simpler. You might try to compare it to springs pulling objects together or ropes transmitting tension, but those analogies fail because springs and ropes themselves are made of atoms held together by electromagnetic forces. The explanations eventually circle back to the same point. Electromagnetism is one of the fundamental ingredients of reality. It is not derived from anything else in everyday physics. Instead, everything else is built on top of it. That idea can feel uncomfortable because the electromagnetic force acts across space through invisible fields. Our intuition prefers contact forces where objects push directly against each other. But as we have seen, what we interpret as contact is really just electromagnetic repulsion happening at extremely small distances. The universe is not made of solid objects bumping into each other. It is made of fields that extend through space and influence particles wherever they appear. When you flip a light switch, the chain of events that follows reveals this hidden structure of reality. A circuit closes. Electrons begin drifting through the wires. A generator at a distant power plant spins inside a magnetic field. That motion produces an electric field that propagates through miles of transmission lines at nearly the speed of light. The field reaches your home and nudges electrons through the filament of a bulb. Resistance heats the filament until it glows. Electromagnetic waves radiate outward and strike your eyes. The electrons in your retina respond. Chemical signals fire, neuron activat, and your brain perceives light. Every stage of that process is electromagnetic. This is why electricity changed human civilization so dramatically. 2 centuries ago, humanity did not understand how to control this force. Once scientists discovered how electric charges and magnetic fields interact, everything transformed. Generators produced electricity. Wires carried it across cities and continents. Motors turned it back into motion. Communication technologies emerged. Telegraphs, radios, telephones, televisions, computers, and the internet. All of it relies on the same fundamental interaction between electric charges and electromagnetic fields. So the next time you flip a switch, remember what is really happening. You are not simply turning on a convenience. You are commanding one of the basic forces of the universe. Electrons begin pushing and pulling on each other across vast networks of metal wires. Fields ripple through space. Energy transforms from motion into electricity and back into motion again. What appears to be a simple everyday action is actually a demonstration of the deep structure of reality itself. Electricity is not just a utility. It is a window into how the universe truly works.